Hi everyone, and thank you for watching this teaser. In this presentation, I will be speaking of the field of fault diagnosis for stochastic systems. Due to their complexity and interaction with an unpredictable environment, every real system will at some point commit some failure. As those failures may have critical consequences, it is important to be able to detect the occurrence of fault. And this is the aim of fault diagnosis. The traditional framework of diagnosis in formal methods are PLTS, Probabilistic Labeled Transition System. To give a quick idea, they are automata enhanced with three elements: a way to describe failures, here in a red, a distinction between internal actions that cannot be observed by the user and the observable actions, and finally, probabilities, as in a Markov chain, that allows to define a probabilistic measure on the set of runs of the system. An external observer tries to deduce whether the current run is faulty from its observation. In this system, for example, observing many bees means the system is highly likely to be faulty. Such a reasoning is strongly related to what is called accurate approximate diagnosis. In the full version of this talk, I will detail this notion, some of the existing or new results on it, as well as point to some useful techniques that can go beyond diagnosis. Thank you.
Hi, this is Karina Pilch. In our paper, Optimizing Reachability Probabilities for a Restricted Class of Stochastic Hybrid Automata via Flowpipe Construction by Stefan Schupp, Anne Remke, and myself, we present a novel approach for computing optimal time-bounded reachability probabilities for singular automata with urgent transition and random clocks which follow arbitrary continuous probability distributions. We therefore use Flowpipe Construction to compute the set of reachable states. From these sets, we extract those valuations of the random clocks which ensure reachability of specific goal states. To compute probabilities, we numerically integrate over those sets using Monte Carlo methods. We restrict to models without continuous non-determinism, and for discrete non-determinism, we consider history-dependent prophetic and non-prophetic schedulers. We present algorithms to compute maximum and minimum reachability probabilities for both of these scheduler classes. In our case study, we demonstrate that our approach for prophetic scheduling is as efficient as the one for non-prophetic scheduling. If you want to get to know more, join Qest session 8 on Thursday. See you there.
Attack trees versus fault trees, two sides of the same coin from different concurrencies. Fault trees were introduced in 1961 at Bell Labs, and they were introduced to evaluate the Minuteman I launch control system. So they were developed to detect failures. Whereas attack trees are similar to threat logic trees, and those trees were introduced in 1991 by Weiss. They were introduced to describe threats on computer systems and possible attacks. So, to detect really harmful attacks. When we take a look at both trees, on the left you see the fault tree with the blue events A, B, C, and on the right you see the attack trees with the orange events A, B, C. Both look really similar. You have the basic events, you have the gate G, and you have a gate T. But are those trees really the same? In which way do they differ? For example, is the propagation of probabilities the same in fault trees and attack trees? On the left, for the fault trees, we have 0.2 as probability for A. We also have this on the right for the attack tree. We set for both the fault tree events B 0.4 as probability, and also for the attack tree event B 0.4, and also both 0.3 for C. Now, while propagating, starting by events A and B, propagating to gate G, and also propagating then C, so the probability 0.3, to the gate T, does this result to the same probability both for fault trees and attack trees? Also, what kind of extensions are there? What extensions are there for fault trees? And what are there for attack trees? Are they also combinations of fault trees and attack trees? And what are they for? In which way do they differ? And what different properties do they have? Among these things and also much more, we will talk on Thursday, 26 August in session 8 at Qest8. In our talk, attack trees versus fault trees, two sides of the same coin from different concurrencies. We're looking forward to you.